In this class, let us study about the Cartesian coordinate system, which is used not only in maths but in physics, astronomy and many other branches of science and technology. Using this system, we can identify the location of points. It starts with something very simple, which is the number line. We know how a number line works. We have 0 in the middle, the positive numbers to the right, and it just goes on to infinity. The negative numbers to the left, and it goes on to minus infinity. Now, if you are dealing with an object which looks like this, it has only length. It is one dimensional. So, this one point of reference is enough. If you want to measure it or if you want to locate points on it, this one line is enough. But what if you are dealing with something which looks like this? It has two dimensions. It has length and it has breadth. Now, for this, we cannot use just this one line of reference. We need another line of reference which will go along this direction. So, that is what we are going to draw. We are going to draw another number line which is pretty much the same. The idea is same. There is a negative side, there is a positive side, and it is separated by 0. And we will draw that line vertically in such a way that the 0 of both these lines will coincide. Now let us draw. Now we have our two lines of reference. So the first line that we drew in such a way that positive numbers come to the right, negative numbers to the left. And the second line such that positive numbers go above and the negative numbers come below, and both these lines intersect at their 0. Wherever the 0 is of both these lines, they intersect there. Now, before we go any further, let us name these two lines. We will name the line which we drew first, which is the horizontal line, or in other words, the sleeping line. The horizontal axis is called the x-axis. And this point which we named O, where the 0 of both these lines coincided, from there to this direction, I will name this x. So, OX will give you the positive direction of x-axis, or in other words, OX has all the positive numbers of the x-axis. Now, this side I will name x dash. So, OX dash will have all the negative numbers. Now look at the vertical line or the standing line. This axis. This is called the y-axis. And this side I will name y. So OY will be the positive direction of the y-axis, and OY dash, I will name this one y dash. This will give you all the negative numbers of the y-axis. And where do they both coincide? These two axes meet at the origin, which is represented by the letter O. Now this whole plane is known as the Cartesian coordinate plane. It is named after Rene Descartes, the French mathematician who came up with this idea. Now, what we mean by a coordinate or a Cartesian coordinate plane is that if you take any point on this plane, say for example here I will take a point. If you take any point on this plane, it can be uniquely represented by an ordered pair. That means A, the location of A. If anyone asks you where is A, the location of A can be uniquely represented by an ordered pair, or in other words by two numbers. The first of those numbers is called the X-coordinate or the abscissa of A. The second number is called the Y-coordinate or the ordinate of A. Now, what are these two numbers? What is the x-coordinate or the abscissa? Now, if you draw a line from A, a straight line from A, where does it meet the x-axis? That is the x-coordinate. So, draw a line straight. Where does it meet the x-axis? It meets it at 4. Right? So, the x-coordinate or the abscissa of A is 4. Now what is the next one? The y-coordinate. If you draw a straight line, so this was supposed to be at 2. Okay. There. If you draw a straight line from A to the y-axis, where does it meet? That point is called the y-coordinate or the ordinate of A. Now this is an ordered pair. What do you mean by an ordered pair? What comes first has to come first. What comes second has to come second. Or in other words, 4, 2 is not equal to 2, 4. These two are not equal. Why are they not equal? 4, 2 looks like this. How will 2, 4 look like? That means from the x-axis 2, from the y-axis 4. Where do they meet? 2 from here, 4 from here. See where they meet? They meet at this point B. Now this point is 2, 4. So these two are completely two different points. 2, 4 and 4, 2 are two completely different points. So each point on this plane is uniquely represented by an ordered pair of two numbers. The first of which we call the x-coordinate, which is the abscissa, and the second which we call the y-coordinate or the ordinate. And this can be for any point in this plane. So now what do we notice? These two axes have divided the coordinate plane into 4 parts. You can see that, like 4 parts. Each part is called a quadrant. This will be the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Now, what is different between these quadrants? Depending on which quadrant your point lies on, its abscissa and its ordinate will have different signs. Suppose the point that I have taken lies in the first quadrant. Then what does it mean? Both the ordinate and the abscissa will have positive sign. What about the second quadrant? Suppose I am taking a point in the second quadrant, say here. See, how will this look like? How will I get the abscissa? I have to draw a line and see where it meets the x-coordinate, x-axis. So I see that it is meeting it at 5 minus 4. And then I have to draw a line to the y-axis and seeing where it meets. I see that it has met at 3. So the abscissa will be negative and the ordinate will be positive. Now what about this area? Here you can see this lies in the negative of x and the negative of y-axis. It lies in the negative of both the axes. So if I take a point here, what will be its abscissa? Its abscissa will be minus 4. And what will be its ordinate? Its ordinate will be minus 2. So any point which lies in this area will have both the abscissa and the ordinate negative. Now we come to the last quadrant, which is the fourth quadrant. How will any point here look like? Always remember, the first one you go is the x-coordinate. Don't go to the y first. First go to the x-coordinates. Now draw a line. Where does it meet the x-coordinate? It meets it at 6. Draw a line from the y-coordinate. You will see that it meets it at minus 1. So in the fourth quadrant, the abscissa is positive and the ordinate is negative. Now, depending on which quadrant a point lies, its abscissa and its ordinate will have different signs, positive or negative. Now, we come to a very important question. You know what we said? We said that this is a Cartesian coordinate plane and every point in this plane is represented by an ordered pair, or in other words by two numbers. one which we call the x-coordinate and other which we call the y-coordinate. But then what about the points on the axis? They are also lying on the plane, right? So the points of the axis also lies on the plane. Then they should also be represented by two numbers, right? So that is what we are going to do next. First, the origin. The origin should also be represented by by an ordered pair, right? So origin, we represent it with the letter O and its coordinates are 0, 0. We know why, because that is how we drew these two lines, so that their zeros coincide. So the x-axis is also 0 and the y-axis is also 0. Now we come to the points on the x-axis. Obviously, their abscissa, it is the x-coordinate, right? Their abscissa will always be the numbers that they have. -1 dash, -2 dash. Now, which part of y-axis, if we were to draw a line from 1 to the y-axis, where will it meet? It will meet with in 0. Here where will it meet? 0. From -3, if we were to draw a line to the y-axis, where will it meet? 0. So, the points on the y-axis look like this. So, if anybody says that what if A lies on x-axis, what do you know about any point which lies in the x-axis? Then you can say that for sure its ordinate will be 0. All the points which lie in the x-axis, remember their ordinate is 0. Now we come to y-axis. Again, the axis itself is y. So you know for sure that this is how the points are going to look. The positive points are going to look like this and the negative points are going to look like this. Now, how will the abscissa look like? From this point, draw a line to the x-axis. Where do you think it meets? Here, draw this is the x-axis. Draw a line. Where do you see it is meeting? From here, draw a line to the x-axis. Where do you think it is meeting? It always meets in 0. Whenever you take a point on the y-axis, here, on the y-axis, then its distance to the x-axis, you will see it always meets in the point 0. So whenever you have a point on the y-axis, on the axis, you will see that its abscissa is 0. Or in other words, if you see any point where the abscissa is 0, for example 0, 21 or 0, -70, whenever you see that the abscissa is 0, then for sure you can say that it lies on the y-axis. Not on any quadrants, not on the first quadrant, not in the second quadrant. It does not lie in any of the quadrants. Instead, it lies on the y-axis. Similarly, if somebody gives you a number which looks like this, you see that its ordinate is 0, then for sure you can say that it lies on the x-axis. It does not lie on any of the quadrants. Now, we have come to the end of our lesson and let us solve these questions. The x and the y-axis are what? Are they parallel? No, they are mutually perpendicular. They are mutually perpendicular. The x and the y-axis intersect at where? The origin. And what are the coordinates of the origin? It is 0, 0. The dash of any point on the y-axis is 0. So what of any point? The abscissa of any point on the y-axis is 0. And the ordinate of any point on the x-axis will be 0. So, the coordinates of which quadrants have the same sign? Or in other words, both the abscissa and the ordinate have to be positive or they both have to be negative. So how do our quadrants look like? Here x is positive, y is positive. And here y will be positive. In this area y will be positive, x will be negative. And here here we have negative y, right? So in this area and in this area, the first quadrant and the third quadrant. In the first quadrant, both the abscissa and the ordinate will be positive. You see what is happening here? The positive side of the x and the positive side of the y meet here. The negative side of y and the negative side of x meet here. So here everything will be positive, here everything will be negative. So the coordinates of the first coordinate, the first quadrant and the third quadrant have the same sign. Here all positive, here all negative. Minus AB lies in which quadrant? In which quadrant is the x-coordinate negative? X-coordinate negative means we are talking about this area. So it should lie in this area, either here or here. So its abscissa is negative. What about its ordinate? Its ordinate is positive, so it cannot come here. So it has to lie in this area, or in other words, it has to lie in the second quadrant. Plot the points which have the same coordinates. That means their abscissa and the ordinate has to be same. So how will it look like? If the abscissa is 1, the ordinate will be 1. So 1, 1, 2, 2, 3, 3. And if it is negative, minus 1, minus 1, minus 2, minus 2, minus 3, minus 3. Will the origin lie in this? Of course, yes. What are the coordinates of origin? It is 0, 0. So if you see the coordinates of the origin, the abscissa and the ordinate are both 0. So these are some of the points which have the same coordinates. So, but how will these points look like? We have to plot these points, right? So let us plot. Now let us start plotting the points. So we need the abscissa and the ordinate to be same. So 1 from here, 1 from here, it will meet at this point. 2 from here, 2 from here, it will meet at this point. We already know the origin also lies here, because for the origin also the abscissa and the ordinate is same. So minus 1 will lie here, minus 2 here. So what do you have? You have a straight line which passes through the origin. So that is how our figure looks like. Now let me ask you one question. Look at these 2 points that I am writing down. Minus 4, 7 and 6, 7. Do you notice something interesting about this? Did you notice that both of their ordinates are same? So whenever you take 2 points whose ordinates are same and you join them in a straight line, you will notice that straight line will always be parallel to the x-axis. Similarly, suppose if I take say 6, 5 and I take 6 minus 3. Then what do you notice here? The abscissa of these 2 points are same. If I join these 2 points in a straight line, you will see that this line will always be parallel to the y-axis. Now you can check these yourself. If you want, I will do it. See, the first one, ordinate minus 4, abscissa minus 4, ordinate 7. So it will come here. Abscissa 6, ordinate 7. It will meet somewhere here. Join this in the straight line. You will see the line that I have drawn is not straight, but just imagine it is a straight line. So this straight line you will see will always be parallel to the x-axis. Similarly, check this out. The abscissa is 6 and the ordinate is 5. So 6 and 5 will come somewhere here, and 6 and minus 3 will come somewhere here. Now I am not going to join this because I don't know if I will be able to join it straight. Yeah, there. So you will see such a line will always be parallel to the y-axis. It is not just for these 2 points. Any 2 points, if your abscissa is same, it will be parallel to the y-axis. and if its ordinate is same, it will be parallel to the x-axis. Given any 2 points on the Cartesian plane, is it necessary to join them with a straight line? Can't we join them any other way? The answer is yes. If you are given 2 points, you can join them whichever way you want. But there is something special about joining them with a straight line. Given any 2 points, say A and B, given any 2 points, the straight line between them gives the shortest distance between A and B. So given 2 points, you join them whichever way you want. But then if you want the shortest distance, if you want to make your life easy, always draw a straight line between them. This was found out by the Greek mathematician Archimedes. As you know, he is known as the father of mathematics. But this thing comes with a catch. You know what it is? This theory works only when the surface is flat. You have a flat surface, then the shortest distance between 2 points is given by the straight line. But if the surface you are taking is spherical, then it won't work. Okay? That is one thing. And another thing, when I started the lesson, this chapter, do you remember what I told you? This Cartesian coordinate system is used in many other branches of science and technology. In one area where it is used daily, your parents also use it. You know where? In the GPS. You would have heard of it, right? The global positioning system. When your parents want to drop you to the school, what do? They will on the GPS, it will tell them which roads have less traffic and which roads have heavy traffic, right? The GPS also uses the same system. What is this system actually? This system actually uses 2 lines of reference. One is the x-axis and other is the y-axis. So it uses 2 lines of reference and enables you to find the location of a point and represent this location with an ordered pair. That is what this does. Okay, it uses two lines of reference. GPS also same. Can you tell me what it uses as the lines of reference? You would have learnt it in geography. You remember longitudes and latitudes? So instead of the x-axis and the y-axis, that is what GPS uses. Now, do you remember in the beginning of the class, what did we start with? We started with just one line of reference. That was for objects which just have one dimension, right? Which has just the length. And from that, what did we do? We went to 2 lines of reference, which was x-axis and y-axis. Why was that? Because we were using 2-dimensional objects. Now, when you go to the higher grade, like the 11th standard and 12th standard, you will have one more axis, and that will be called the z-axis, and all the 2 of them. With 2 lines of reference, it looks like this, right? 3 lines, it will look like this. 3 lines of reference will look like this. So this will be x, y, z. And this will be used when you are dealing with 3-dimensional objects. But for now, we don't need this. We will cross the bridge when we come to it. For now, just 2 lines are enough. We are happy with this. So inshallah, till I meet you next time, you stay safe. Assalamu alaikum.